So welcome back to Databricks Certified Data Engineer Associate Part 1. In this session, we will be covering Databricks Lakehouse platform related scenarios and tips. As I already mentioned, there will be 24% weightage for this topic in this exam. Let's find out some scenarios. So before going to scenario, I think it's good to understand Databricks workspace and service architecture. So if you look at this, you are going to see control plane and data plane. You will have some questions related to control plane and the data plane in the exam. What they will be looking for, what is part of what? So whether the web app is part of a control plane, whether the cluster is part of data plane. Looking at this architecture, you understand, no, under control plane, we have the web application, cluster manager, workflow manager, jobs, the notebooks, repos, DBSQL. Then we have something called Unity Catalog, which is the governance part of Databricks, which has the meta store, access control, data lineage, and explorer. So it's clear that these topics, like whatever is something is administrative panel, that's all belongs to control plane. And what we look at data plane, you are seeing that we have the clusters and the SQL warehouse and the data stores and everything that related to data is going to data plane. And we have also something called cloud storage. The data, the data, the business data, okay, the account data is being stored in some cloud storage. So control plane, data plane, and cloud storage. The cloud could be Microsoft Azure, AWS, S3, whatever it is. So the data can be situated in any of these cloud providers. So that's all about some architecture of Databricks. Then very important topic is Databricks repositories. You know, Databricks handles notebook. You can write your code in SQL, in Python or Scala, and you need to when you are working in a group or a team, of course you need to manage your data source data, right? So you have to maintain a version control system, and of course the database can integrate with Git repositories, and you can do the check-in, you can do checkout, you can save the code, and you can maintain the commit, you can merge conflict, you can do even integrate the CSID pipeline. But the question is, what is possible with the Databricks repo? What is possible with the provider? So make sure you understand the Databricks repository features, especially what is possible with the Databricks repository. Like, sometime the create a pull request is not allowed in the Databricks repository, that you have to go to the provider interface. You may not be able to do a merge or delete branches in the Databricks repos, and you cannot rebase the branch. All these are not possible with the Databricks repository. So what you have to do, you have to go to the provider interface and do such kind of activities. So this type of questions are there in the exam. Then coming to cluster, okay, so the cluster is the compute engine behind the Databricks, and it helps you the scalability of performance and all the features you are getting from the clusters. There are different types of cluster, basically the all purpose clusters which you are going for interactive development. You have job clusters for automating workloads. So remember, you will have some question related to clusters in this segment, okay. So these are some of the tips which I would like to share before I go to the scenarios. Also, you need to understand some of the keywords like Delta Live Table, that is DLT, Delta Lake, Apache Spark, Unity Catalog, Photon. So while we were preparing, like, this is how I just understood all the concepts and some of the key terms, then their explanation, and that would really help you achieve uh, the certification. So let's move on to the scenarios. So first scenario, Which of the following is hosted completely in the control plane of the classic Databricks architecture? Let me give you some tips. The worker node, JDBC data source, Databricks web application, Databricks file system, and driver node. It is very clear that the answer is Databricks web application because none of these are kind of a manager console, right? They are mostly other utilities. They don't belong to the control plane of the Databricks. So the answer is Databricks web application. So scenario two, which of the following benefits using the Databricks Lakehouse platform is provided by Delta Lake? Then you need to understand what's a Delta Lake, right? So in the previous slide, I was just trying to show you what is Delta Lake. So Delta Lake, an open source storage layer that brings asset transaction, schema enforcement, and time travel to data lake. So if you would like to enjoy these asset transaction, schema enforcement, and time travel to the existing data lakes, I think we may have already worked on data lakes, but we don't have this feature. We don't have asset transaction, right? So that feature is provided by Delta Lake. So now let us the question and answer again. So which of the following benefits of using Databricks Lakehouse platform is provided by Delta Lake? Option 1 is the ability to manipulate the same data using a variety of languages, the ability to collaborate in real time on single notebook, the ability to set up alerts for query failures, the ability to support batch and streaming workloads, the ability to distribute complex data operations. Out of these five options, we have the ability to support batch and streaming workload is provided by the Delta Lake. Then we have a scenario, the scenario where the leader is seeing different disparity in the reports generated by different teams. So when different teams generate the report, they see a different disparity between the values or the pattern. So because they may not be using the similar source, right? So which of the following describe how a data lakehouse could alleviate this issue? The tips are both teams would auto scale their work as data size evolves. I think this is impractical. Both teams would use the same source of truth for their work. Yeah, it's very close. Both teams would recognize to report to the same department. The both teams would reorganize to report to the same department. Both teams would be able to collaborate on project in real time. Both teams would respond more quickly to ad hoc requests. So what would be the answer for this? The answer is nothing but both teams would use the same source of truth for their work. That is the benefit of data lakehouse. The data lakehouse is going to give you a single source of truth. Then scenario 4, one of the fundamental technologies provided by Databricks Lakehouse platform is an open source file-based storage format that brings reliability to data lake. Which of the following technology is being described in the above statement? So already we have seen this technology, maybe Delta Live Tables, Delta Lake, Apache Spark, Unity Catalog, and Photon. There is no doubt it is Delta Lake. Already we have explained the what the Delta Lake brings on your table. Then going to scenario 5, in Databricks repos, which of the following operations a data engineer can use to save local changes to a repo to its remote repository? This question is related to repository. So let's see what are the actions. Create pull request, commit and pull, commit and push, merge and push, and merge and pull. So here you can you can know that the create pull request cannot be executed from the uh, Git from the Databricks repository. Then can we do commit and pull? Can you do commit and push? Can you do merge and push and merge and pull? So let's see. The commit and push is the answer. Which of the operations a data engineer can use to save local changes of a repo to its remote repository? So we are saving our changes to a remote repository by commit and push. So scenario 6, a delta lake tables. Which of the following is the primary format for transaction log files? Now maybe you get confused. It is not asking about the data file, it is asking about the transaction log file. The data file, of course, we know that is stored in a Parquet file format, whereas the transaction log files are stored Delta, Parquet, JSON, Hive specific format, or XML. So remember that transaction logs are stored as JSON. Following Git functionalities can be performed in Databricks repos. So there are functionality which cannot be performed or can be performed. This is can be performed. Let's look into the options. So we have create a pull request, create resolve merge conflicts, merge or delete branches, rebase a branch, pull from a remote Git repository. I know it is very clear that no some of these actions, like especially the create a pull request, cannot be done. Resolve merge conflict partially may be done. The merge or delete branches not possible. Rebase a branch not possible. Pull from a remote Git repository is possible from the Databricks repos. Then coming to scenario 8, which of the following locations completely host the customer data? So where is your customer data is hosted in Databricks? It's a very important question. We can say customer cloud account, control plane, Databricks account, Databricks managed cluster, or repos. So looking at this answer, you can very clearly say these things questions are not at all relevant. These answers are not relevant. Relevant answer is customer cloud account. Customer cloud. I already mentioned like we have Azure, we have GCP, or we have Amazon. Wherever you have yes, you have the cloud account, the data is stored there only. Then coming to another scenario, which of the following services provide a data warehousing experience to its users? If you're an ETL person, you know what is the feature of data warehousing. It is basically a structured data warehouse, right? So in Databricks, which service provides a data warehousing experience? Let's see the options. We have Databricks SQL, probably that is very close. Databricks machine learning, data science and engineering workspace, Unity catalog, Delta live table. Delta live table is basically used for streaming data. Here, these options are not valid at all. What is valid is Databricks SQL is the valid answer. Coming to scenario 10, which of the statements are incorrect when choosing between Lakehouse and data warehouse? So as you approach the Databricks, it is ideal that you should understand Lakehouse concept and data warehouse concept. What are the options here? Lakehouse can have special indexes and caching which are optimized for machine learning. Lakehouse cannot serve low query latency with high reliability for BI workloads. It's only suitable for batch workloads. Let's take this option. Then Lakehouse can be accessed through various APIs, including but not limited to Python, R, or SQL. That's really true. Traditional data warehouses have storage and compute are coupled. Then finally, Lakehouse uses standard data format like Parquet. Could be true. So what is wrong here? The wrong answer is Lakehouse cannot serve low query latency with high reliability for BI workloads. It's only suitable for batch workloads. This is absolutely wrong, and that is our answer too. Then coming to scenario 11, which of the statements are correct about Lakehouse? Lakehouse only support machine learning workloads and data warehouse supports BA workloads. Lakehouse only supports end-to-end streaming workloads and data warehousing support both batch workloads. Lakehouse does not support ACID. In Lakehouse, storage and compute are coupled. Lakehouse support schema enforcement and evolution. The question is, which of the statements are correct about Lakehouse? I would say all these four options are wrong. The correct answer is Lakehouse supports schema enforcement and evolution. Which of the following are stored in the control plane of Databricks architecture? Let's see the options. Job clusters, all purpose clusters, Databricks file system, Databricks web application, and Delta table. So if you already listened to the previous questions, you will understand that these are not part of the control plane. What is part of the control plane is Databricks web application. Then coming to another scenario, you have written a notebook to generate summary data set for reporting. Notebook was scheduled using the job cluster, but you realized it take 8 minutes to start the cluster. What feature can you be used to start the cluster in a timely fashion so your job can run immediately? Option: set up an additional job to run ahead of the actual job so the cluster is running second job starts. Use a Databricks cluster pools feature to reduce the startup time. Use Databricks Premium Edition instead of Databricks Standard Edition. Pin the cluster in the cluster UI page so it is always available to the jobs. Disable auto termination so the cluster is always running. So out of this, and the apt answer is use the Databricks cluster pools. So anything related to the speedy start, that all belongs to Databricks cluster pools. Okay. So coming to another scenario, which of the following developer operation in the CI/CD can only be implemented through a Git provider when using Databricks repos? What are the options? The trigger Databricks repos pull API to update the latest version, commit and push code, and edit code, create a new branch, pull request and review process. Out of these options, the correct answer is pull request and review process. Others are not possible. Then scenario 15, you have noticed the data scientist team is using the notebook versioning feature with the Git integration. You have recommended to switch to using Databricks repos. Which of the below reason could be the reason the why the team needs to switch to Databricks repos? Very good answer. So if you are using a notebook version and you want to switch to Databricks repos, what is the additional benefit you are going to get? Answers: Databricks repos allow multiple users to make changes. Databricks repos allows merge and conflict resolution. Databricks repos has a built-in version control. Databricks repos automatically saves changes. Databricks repos allow you to add comment and select changes you want to commit. Of course, let's see what is answer. The Databricks repos allow you to add comments and select the changes you want to commit. Okay, so you should focus on some of the feature of Databricks repos because I have seen couple of questions from there. So how are delta tables stored? Delta table stored. Earlier we saw how the transaction tables are stored. Let's look the tips. A directory where packet data files are stored. A subdirectory delta underscore log where metadata and the transaction log is stored as JSON file. A directory where packet files are stored, all of the metadata is stored in memory. A directory where packet data files are stored in data plane. A subdirectory delta underscore log where metadata, history, and log is stored in control plane. A directory where Parquet data files are stored, all of the metadata stored in a Parquet file, data is stored in the data plane, and metadata and delta logs are stored in control plane. So out of these four, we have one option correct, that is a directory where Parquet data files are stored, a subdirectory underscore data underscore log where metadata and the transaction log is stored as JSON files. Got it. So remember that transaction files are stored as JSON and data files are stored as Parquet file, and they have a folder structure as you see here. These are the Parquet file, these are the JSON log files. So it follows a specific data structure. So when you study your scenarios, you have to try to relate to some images, some answers, so you will be you can remember it easily. So scenario 7, while investigating a performance issue, you realize that you have too many small files for a given table. Which command are you going to run to fix this issue? Let's see the options. Compact table name, vacuum table name, merge table name, shrink table name, optimize table name. So here you have to importantly remember vacuum and optimize. These are very much important to Databricks. We'll come to see about vacuum later. In this case, the answer is optimize, and optimize can actually do what can do. It can improve the performance. Okay, you have too many small files, so you want to fix this file, and for that you have to use optimize. Scenario 19, what is the best way to describe a data lakehouse compared to a data warehouse? So data lakehouse provides a relational system of data management. A lakehouse captures snapshots of data for version controls purpose. A data lakehouse couples storage and compute for complete control. A data lakehouse utilizes proprietary storage format for data. A data lakehouse enables both batch and streaming analytics. So out of these five options, you should remember the answer is data lakehouse enables both batch and streaming analytics. So next scenario, you are designing an analytical store to store structured data from your e-commerce platform and unstructured data from your website traffic and app store. How would you approach where you want to store your data? The question is like whether you want to go for data warehouse or data lakehouse and so on. So some of the options are use traditional data warehouse for structured data and use data lakehouse for unstructured data. Data lakehouse can only store unstructured data but cannot enforce a schema. Data lakehouse can store structured and unstructured data and can enforce schema. Looks like this is the right answer. Traditional data warehouse are good for storing structured data and enforcing schema. But we have both structured data and unstructured data, and what will be our option? The strategy will be data lakehouse can store structured and unstructured data and can enforce schema. So our option will be data lakehouse. Scenario 21. Which of the following describes how Databricks repos can help facilitate CI/CD workflows on the Databricks Lakehouse platform? Look at the options. Databricks repos can facilitate the pull request, review, and approval process before merging branches. Databricks repos can merge changes from secondary Git branches into a main Git branch. Databricks repos can be used to design, develop, and trigger Git automation pipeline. Databricks repos can store the single source of truth Git repository. Databricks repos can commit or push code changes to trigger a CI/CD process. So that's what we are looking for. Databricks repos can commit or push code changes to trigger a CI/CD process. So scenario 22, you notice that a colleague is manually copying the notebook with underscore BP to store the previous versions. Which of the following feature would you recommend instead? You don't recommend to copy notebook. Instead of that, there is some feature that we can use. The tips, Databricks notebook support change tracking and versioning. That's a very good feature. Let's see if that is the answer. Database notebooks should be copied to a local machine and set up source control locally. to version the notebooks? That's not the answer. Databricks notebooks can be exported into BC archive files and stored in the data lake. Finally, Databricks notebooks can be exported to HTML and imported at a later time. So, out of these four options, we hope Databricks notebooks support change tracking and versioning. Let's recommend that. How does Delta Lake differ from a traditional data lake? It's because of some feature, right? Delta Lake is a data warehouse service on top of data lake that can provide reliability, security, and performance. Is that the right answer? Delta Lake is a caching layer on top of data lake that can provide reliability, security, and performance. Delta Lake is an open storage format like Parquet with additional capabilities that can be provided reliability, security, and performance. Looks like this is closer to the answer. Delta Lake is an open storage format designed to replace flat files with additional capabilities that can provide reliability, security, and performance. Let's see the last option. Delta Lake is proprietary software designed by Databricks that can provide reliability, security, and performance. The answer is Databricks Delta Lake is an open storage format like Parquet with additional capabilities that can provide reliability, security, and performance. Scenario 24. Which of the following is the correct statement on how the data is organized in a storage when managing Delta table? Basically, it is asking you how your files are stored, how the transactional files are stored. So remember that when you are storing in Delta Lake, the transaction files are stored as JSON, but it creates a multiple copies, and the data files also having multiple files, and the format is Parquet file. So let's look at the option. All the data is broken down into one or more Parquet files. Log files are broken down into one or many JSON files, and each transaction creates a new data file and log file. Second option is all the data and logs are stored in a single Parquet file. It is impossible. All the data is broken down into one or many Parquet file, but the log file is stored as a single JSON file, and every transaction creates a new data file and log file gets appended. This is also not correct. All the data is broken down into one or many Parquet files. Log file is removed once the transaction is committed. This is also not right. All of the data is stored in one Parquet file. Log files are broken down into one or many JSON files. So the answer is all of the data is broken down into one or more many Parquet files. Log files are also broken down into one or many JSON files. Each transaction creates a new data file and log files. What is the underlying technology that makes an auto loader work? And the auto loader, when you have to load a millions of records and you want to load it incrementally, you should go for autoloader. And what is the technology behind that? Is it loader, Delta Live Table, structured streaming, data frames, or live data frames? The answer is structured streaming. So remember, when you talk about autoloader, the technology, structured streaming is the answer. Scenario 26, you are currently working to ingest millions of files that get uploaded into cloud object storage for consumption, and you are asked to build a process to ingest this data. And the schema of the file is expected to change over time, and the ingestion process should be able to handle this change automatically. Which of the following method can be used to ingest the data incrementally? Of course, we have some options. We have auto append, we have auto loader, we have copy into, we have structured streaming, we have checkpoint. The structured streaming is a technology behind auto loader. So we have to choose whether auto loader, auto append. That's not an option. Auto loader could be an option. Copy into doesn't work with the millions of files. It's working with a small quantum of files. And checkpoint is used for incremental loading. So the answer is auto loader. So scenario 27, which of the following locations in the Databricks product architecture host a notebook and jobs? The data pane, control plane, Databricks file system, JDBC data sources, Databricks web application. So it's nothing but the control plane. That is where our notebooks and jobs are hosted. Scenario 25, 28. If you create a database sample BP with a statement create database sample, what will be the default location of the database in DBFS? The default location is dbfs colon user, dbfs slash user slash db, default storage account, then statement will fail, and the default location dbfs colon slash user slash hive slash warehouse. The answer is the last one. It is the warehouse. That is the default location. Then coming to the scenario 29, which of the following statements are true about Lakehouse? We have seen many questions about true or false about Lakehouse. So remember, your question, you have a lot of questions related to this. Lakehouse only support machine learning workloads and data warehouse supports BI workloads. This is not correct. Lakehouse only support end-to-end streaming workloads and data warehouse support batch workloads. This is also not correct. The Lakehouse does not support ACID. Not correct. Lakehouse do not support SQL. That's also not correct. Lakehouse support transaction. That is correct. So what is correct about Lakehouse? This Lakehouse support transaction. Then coming to the scenario number 30, a data engineer needs to determine whether to use the built-in Databricks notebooks versioning or version their product using Databricks repos. Which of the following is an advantage of using Databricks repos over the Databricks notebook versioning? Similar questions we have already seen. So let's see the option. Databricks repos automatically saves development progress. Database repos support the use of multiple branches. Database repos allows user to revert to previous version of the notebook. Database repos provide the ability to comment on specific changes. Database repos is wholly housed within the Databricks Lakehouse platform. So we already seen the result. Database repos provide the ability to comment on specific changes. That is why we are going with repos instead of the Database notebook versioning feature. So scenario 31, which of the following Git operation must be performed outside of Database repos? Is it like commit, pull, push, clone, or merge? So we can do commit, we can do push, we can do pull, we can do merge, but we cannot do clone. We have seen 30, 31 scenarios from this data lakehouse topic. I wish these tips can really help you um, get through this exam. So all the best. We will see another video with the next topic, ETL with Spark, SQL, and Python, which is having 29% weightage. So very important topic, Spark, SQL, and Python. Look for the next video. Thank you.